All right, so I'm going to go over mixed questions number 4. This is the last packet that I'm going to be doing with my classes. So sorry for the background noise. I do have students in the room right now, but it is what it is. So let's see, name, it's still me. Let's see, so I'm going to graph this. So I want to find my asymptotes. So first thing I like to do is look at the bottom and go, okay, what's going to make the bottom equal to 0? And so what's going to make x minus 2 equals 0? Well, if we add 2 to both sides, we get x is equal to 2. So that's going to be my vertical asymptote. And it doesn't cancel with the top, so we know that's true. So we go to 2, we're going to draw on our vertical asymptote. Then horizontal asymptotes. So horizontal, x squared minus 1 over. So I look at that, I go, oh, I got x squared on the top. So that's the biggest I see anywhere. So I have 0x squared over, I'm silly, I meant to say 1x squared. On the bottom there aren't any. So this means that there is no horizontal asymptote. But the slant, remember the way that we do the slant is we do that long division. We go long division, we got x squared plus 0x minus 1. Then we put the x minus 2 up front. X goes into x squared, x times. Do the x times the x minus 2, we get the x squared minus 2x. And then I gotta be careful here because I'm subtracting, right? So the x squared minus the x squared, they cancel. Then the 0 minus the negative 2. 0 minus negative 2. We're adding those then, so it's going to turn to 2x. And so I say, okay, how many times does x go into 2x? Well, it goes in 2 positive times. And so that, remember, we stop there. We don't have to do any more than that. So y is equal to x plus 2 is my slant. And so if I go over here, I can use my calculator if I'm not sure. But I go up to my y-intercept of 2, and I draw my slope of 1 over 1, and I got my slant asymptote there. All right, y-intercept, that's where we plug in 0 for x. So remember that if my vertical asymptote wound up being at 0, then we wouldn't have a y-intercept. Or I can just look at the picture, and that works too. So if I plug in 0 for x, I get x squared minus 1 over 0 minus 2. I get negative 1 over negative 2, which is a half. So my y-intercept is 0, comma, a half. All right. And then we just got to see if there are any x-intercepts. And so the way we do x-intercepts is we solve the top. And so we got our x squared minus 1. And we just go, hey, that factors to x plus 1 times x minus 1. And we solve it, and we get x is equal to negative 1, or x is equal to 1. And so negative 1, 0, and 1, 0 are going to be my two x-intercepts. So remember that we follow the asymptote. We just kind of go through the points that we have and follow the asymptote. Then on this side, I don't have my calculator on me, but it's going to be like this. I'm going to have to get it later. But yeah, there's our picture. So that's question number 1. You might notice I'm going a lot faster this time. I go a lot slower through packet number 1, so you can watch that video if you have any more questions, or find me or Miss Lycon. We both want to help. All right. So our next question says f of g of x. So that's where we take f of x, we drop it down, we go 3 minus x. We rip out the x, and we stuff g in its place. And then we'll simplify. So I can distribute that negative. 3 minus x squared, because a negative times that turns it negative, negative times a negative is going to turn that positive. So 3 and the 2 are going to combine like terms to a 5, and that x squared is going to chill. So that's f of g of x. G of f of x, okay. So for g of f of x, take g, drop it in place, rip out the x, leave everything else the same, and then stuff in the f. Now I gotta actually simplify this, so that says 3 minus x squared. So that means I'm gonna have to go in here and be careful, and so I'm gonna use the box. You can do whatever you want. You can FOIL it out, it doesn't matter. 3 times 3 is 9. Negative x times 3 is negative 3x. 3 times negative x is negative 3x again. And then negative x times negative x, that's a negative times a negative, that's a positive x squared. You might hear Miguel in the background. He is slowly peeling the Band-Aid off instead of ripping the Band-Aid off. Sorry. Okay, so we have 9 minus 6x, because the 2 3's combine, and then plus x squared minus 2. So we can combine, like, you can pull it more, it's fine. There's going to be a little background noise on this. It's not going to be like... Then we got 7 minus 6x plus x squared. Okay. So determine whether these are inverses of each other or not. Show all work. So, remember, that's where we just take them and we plug them into each other. If we get x, they are. If we don't, they're not. So I'm going to start out and do square root of x plus 2, rip out the x. And I'm going to plug in the x squared minus 2x plus 4, where x was. I don't know the square root of that. This is not x, so they're not inverses. Just to show you, you know what? No, I'm done. Since that wasn't x, they're not inverses. We're done. Otherwise, what we would do is we would take this one, our x squared minus 2x plus 4. We'd rip out the x, and then we'd stuff in the x plus 2. And we just need to show that if it equals x, then great, they're inverses. If it doesn't, then they're not. So, all right, let's keep going. All right, we're back. So, so now we're going to do this one. And remember, the big deal with this one is you focus over here on the right-hand side of it first. You figure out what that is, and then you use that number to do the left one. So it says, I'm not even going to pay attention to that part, f of 2. So it says g, that says f. Why are they backwards? Anyway, so I'm going to go to f of 2. So I go to x value 2. So it's 2 comma, let's see, negative 2. So now this question is really asking me, what is g inverse of negative 2? So we got negative 2 when we found that. What is g inverse of negative 2? So I go over to g, and remember this negative 2, this is really asking me, hey, what's the y value of the inverse? So if I want to know the y value of the inverse, g inverse has x of negative 2 and a y of we don't know. That tells me then that g has a y of negative 2 and an x of we don't know. And so we can go and we can look that up over here. Okay, well, g has a y value of negative 2. Let's see. Looks like it hits a y value of negative 2 right here. Then that means that g has the point negative 4, negative 2. If g has that point, its inverse has the swap of it. Negative 2, negative 4. And so the answer to this part is negative 4. And now that we've did that and then it collapsed into that, then we're done. We get negative 4. So there we go. So then for our next part, it says f of, now this one starts with an inverse. It says, hey, find the inverse of negative 1 of g. So remember that that's saying the y of our original is negative 1. And so I want to go, oh, here's my y value of negative 1 in my original. My x value is negative 2. So it's really just asking what is f of negative 2. And so I go into f, plug in negative 2 to x, and I get out 1 for y. All right. So now we've got f of x is equal to x plus 2 squared. Restrict the domain so that the function is 1 to 1 and has an inverse. So if we graph this and we look at it, we can go to our calculator if we're not sure how this works, but this is a parabola that gets moved 2 to the left. So it's going to look like this. If we restrict its domain, instead of its domain being all real numbers, we just got to chop off the left half here. And so its vertex is at negative 2, and so we can say that its domain is negative 2 to infinity. And then its range, well, lowest it ever gets is 0, so its range is going to be 0 to infinity. So now this is something called a one-to-one function, and it has an inverse. And we want to state, so this is f of x's domain and range. Remember that with inverses, domain and range swap. So its inverse will have the domain of 0 to infinity and a range of -2 to infinity. So that handles that. So remember, these two flip-flop when we put them into the inverse. So the big deal is on these sorts of things, wherever it starts to kind of mimic itself on the other side, that's when we want to cross it off and be like, okay, so instead of being everything, it's just going to start here and go on. Okay. All right, I got to pause real quick. All right, so I needed a calculator for this one. Yeah, calculator. The temperature of an object placed in it, blah, 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 blah. Oh, T is time in minutes after the object is placed in it. So T is time in minutes. Okay, good to know. Estimate the temperature of the object 22 minutes after it's placed in the freezer. So we literally just take 88e to the -0.055, plug in 22, and that's it. Right, okay. I got 26.24 degrees Fahrenheit. Now I knew Fahrenheit, I just peeked up here real quick and I saw that. So that's literally all I have to do for that question. How long will it take for the object to reach a temperature of 15 degrees Fahrenheit? All right, so I'm going to find the answer before I find the answer. So it's cooling down, so that means it's going to take more time. What about 32 minutes? That was a good guess. All right, that was an actual guess. Try 31 minutes. No, wait, no, I haven't quite reached 15 yet. I'm still a little bit warmer than 15, so let's do 33 minutes. So between 32 and 33 minutes, so I could do like 32.5 minutes. Let's do less than that then. Hey, so 32.1. Yeah, so I could say 32.1 or 32.2 minutes, and I think either of those would definitely be okay. But now let's actually solve this. So I'm going to take my 88e to the -0.055t, and I'm going to set that equal to 15 degrees. So the way that we solved these was we divided both sides by that number out front. And so we got e to the -0.055t is equal to 15 over 88. I don't know what that is. So, nah, I'll just leave that as 15 over 88. And then we take the natural log of both sides, so I get -0.055t is equal to ln of 15 over 88. Divide both sides by the -0.055. I got 32.16, so, or 17. There we go. So again, either of those methods are fine. All right, prove the following identity. We can start on either side. I like to start on the more complicated side. So I see over sign, and then I already see where this is going to go. I'm actually going to make them and combine them. So that's sine over 1 right now. So I'm going to multiply it by sine over sine, which is going to be cosine squared theta over sine theta, plus sine squared theta over sine theta. So now we can mush them together and have them both be over sine theta, and cosine squared plus sine squared. And if you don't recognize that, it is reversed, but it's our Pythagorean identity. Sine squared plus cosine squared equals 1. And so I can replace the top with 1 and get 1 over sine. And I can rewrite that as cosecant. Hey, that's what we wanted. We're done. All right. So let's keep going. This one I've got sine 80 cosine 140 minus sine 140 cosine 80. So I look at my 4 formulas, and sine, let's see, I've got sine, cosine with a minus in the middle. Sine, cosine, sine, cosine with a minus. It goes UV and then VU. So it like goes one and the other and then they switch. So then they switch. Okay, so this is really sine of U minus V. This is going to be sine of negative 60. Let me just double check. I'm feeling a little out of it today, so I'm just worried that I did my basic. Nope. All right, so sine of negative 60. Remember on our unit circle, that's going to be, instead of 60 up here, it's going to be the negative version of it down here. So an easy way to remember what's going on here, well, we know sine of 60, we can use our unit circle, or if we don't remember, we can plug it in, but it's root 3 over 2. So then that means that down here, it's going to be negative root 3 over 2. Or another way to think about it, using our identities that we learn in honors, sine of negative u is equal to negative sine of u. So sine of negative 60 is equal to the negative of sine 60. All right. Second to last question. The pressure in an air tank rises and falls in regular 3-minute cycles. Oh, there's my period, right? The air pressure starts at 70 and rises to 90, then drops all the way to 50 before the cycle continues again. So we're at 70, 90, down to 50. So it's going up 20, then down 20. That tells me that the amplitude is going to be 20. So we're going to say 20. Number of minutes, so 3-minute cycles. So then I can say, we know that B is equal, so this is Y is equal, sorry, A sine BX minus C plus D. So we know that off of our middle line, it's rising and falling 20. We got sine. Our B is going to be this, we got to figure out what it is with that 3-minute cycle. So you can remember from the formula sheet, B is 2 pi over period. So 2 pi over our period B, which is 3 minutes. Oh, so it's just going to be 2 pi over 3. Or we could get the decimal if you want. And then it's not moved left or right at all. It is, but if it's not, the middle line is not 0, the middle line is 70. So we'll say plus 70, and we'll be good. All right, so for our last question here, it says find the domain and range of f of x equals sine of x. Well, remember sine of x is like, woo, like that, right? Bouncing from -1 to 1. So we know the range is from -1 to 1, and we put the little boxes on it because it hits the -1 and 1. So that tells us that the domain of its inverse is going to be from -1 to 1. So now if we talk about the domain of sine, the domain is all real numbers. Or we can write that symbol, or we can say -infinity to infinity, you know, whatever you want to do there. But when we go down to the range of inverse sine, remember the range of inverse sine is not actually going to be -infinity to infinity, but instead it's going to be one complete cycle centered around 0, and so it's going to go from -90 to 90. And you could use radians. You could say -pi over 2 to pi over 2. All right, hope this was helpful. And yeah, again, any questions on any of these, on any of this stuff, feel free to reach out to me or Ms. Lycon, whether or not you're my student, and I'm sure whether or not you're her student, because we like to help you guys. So have a good one.